So thank you, Jared. And so I would like to introduce our speaker tonight from Covenant Technology Partners. His name is Pierre LaFromboise, and he's the Director of Business Analytics at Covenant Technology Partners. And Pierre is, well, like a lot of us, has worn a lot of hats throughout the years. Been a system administrator for an ISP and web designer. And anyway, without further ado, I'll turn it over to Pierre. Pierre, take it away.
Thank you very much. Good evening, everyone. So I'm here to talk to you guys about kind of Microsoft's vision for a modern data warehouse architecture. And I want to start here with our agenda and kind of setting the stage of what we're going to talk about. This is meant to be a very kind of high level discussion around the journey from more of a traditional data warehouse and kind of walk through the concepts of what is driving some of these modern concepts and what are even these modern concepts, just to kind of set the stage. This is not a technical, or at least a highly technical discussion in any way. It's more just to provide a basic kind of understanding of where data warehousing and business intelligence and data analytics, or whatever we want to call it today, is heading, and quite frankly is already there for a lot of organizations. We should have plenty of time for questions at the end, but if anything is pressing, feel free to chime in. I don't mind addressing any of it. But we're going to start by just kind of setting the picture, just very, very briefly, just talking about what a traditional data warehouse kind of architecture looks like, traditional data warehouse lifecycle. Then we're going to go into what are some of the drivers that are leading us to a more modern or a new solution. And we're going to define what those characteristics of a modern data warehouse are. Excuse me. And then we're going to break it into some foundational components. Specifically, we're going to be mapping this to some of the Azure services, since we're talking about it from a Microsoft perspective. Then we'll kind of come full circle and discuss a little bit around what the modern data warehouse architecture looks like and lifecycle, and we'll contrast that a little bit to what we saw at the beginning here with a traditional data warehouse. And then finally, we'll jump into a little bit around Azure Synapse and do kind of a quick demo. And just from the demo perspective there, it's more of a trying to give you an understanding of the landscape of Synapse more than any sort of deep dive or anything. But again, I'm more than happy to answer any questions that you guys may have around that. And we'll talk about how Synapse fits in here and so on when we get there. So starting off with the traditional data warehousing. This is a diagram pulled straight from one of the old Kimball data warehousing books, kind of showing what a mature data warehouse platform may look like, where we have a number of incoming sources, almost always some sort of database platform, in this case, some sort of relational system. It could also be more legacy, like a mainframe system and so forth, but it's almost always a transactional system that's leading to this, and we'll talk about why that's important in a moment. But it goes through a ETL layer, so we're extracting, transforming, we're manipulating that data, cleaning it up, normalizing the data, that sort of thing, and then ultimately it'll land in some sort of storage layer. In this particular diagram, we have a little more of a mature environment where we actually have a formalized operational data store, which is normally a forklift of the data. It'd be much closer to what you would see in the operational side of this. And the concept here is to speed up our time to market, really, of this data from going from operational system into an analytics system. So we have minimal transformation when it hits this layer. We also have a metadata repository. In a traditional system, this would usually consist of a master data management system where we are mastering data across disparate operational systems, and again, getting kind of down to a golden record concept. And then ultimately, that flows into an enterprise data warehouse. We're not really going to go into the minute details of what we define as an enterprise data warehouse here, But in kind of that traditional model, this would be a dimensional data warehouse in most people's cases. That then could feed a number of purpose-built data marts. In Microsoft's world, this would be very likely, kind of at least in the past, this may be an analysis services cube or something along those lines. So things that I want to point out here is this is a model that has been in place for over 30 years, and it's largely worked well for over 30 years. Certainly doesn't mean that's perfect in any way, but I would point out that this still works. This is still something that many, many organizations rely on today, and it's not necessarily inherently bad on its own. That is not why we have some of these modern systems, and modern systems are also not there just because they're the latest cool thing. They do have very specific use cases that we'll walk through. But one of the things that I'd look at in this kind of a model is that this tends to be largely monolithic in nature. We need some level of all of these components in order for it to truly be effective. You can't really pull out any of these. Now, there might be different levels of maturity of these in an organizational data warehouse, but they're pretty much all needed in one form or another. It's also typically built around very well-defined and well-known kind of use cases. We have well-known operational systems, and that data is flowing through to support our business processes. These type of models don't typically support bringing in third-party data or maybe vendor data and some of these other just kind of smaller curated data sets. This tends to be a much more formal environment that is owned by some sort of group, usually IT, but sometimes in a formal company, they'll have a distinct business intelligence group. But again, think of it almost as a monolith. This is, although there's a lot of little boxes on here, it is one beast from our perspective from a data warehouse. Life cycle wise, we tend to end up with very kind of long, linear, waterfall style project methodology that goes into a life cycle here. There's usually more than one path. You'll see in this diagram, again, this is another thing pulled kind of from the Kimball methodology. We have data modeling paths, we have infrastructure and technical architecture paths, we have more on the project planning and support paths, but it tends to, again, be a very large monolithic product. And because of that, you tend to have very large project cycles. It is definitely not unusual to have, a data warehouse project, go 18, 24 months before you actually even have any sort of end results. So again, think of it as linear. Even in a more modern sense where they try to make this more agile, it tends to be broken into a bunch of little miniature waterfall projects as opposed to a true kind of agile development process. So that does bring us into what are our drivers for something different. We have three main drivers, and it's around this agility, cloud, and return on investment. I guess I'd probably argue that all of this really comes down to return on investment in the end, but there are some distinctions here around agility and cloud. We know a lot of organizations, especially when you take into account things like this pandemic, are moving to a much more virtual type of infrastructure where maybe their human resources are spread out and not as centralized in an office or whatever it happens to be. That is very much driving this kind of on-demand cloud services, but also just our ability to react to our changing business needs. Again, you can use the pandemic as a perfect driver for that. It wasn't necessarily something that organizations were planning for, and so they need to be able to react quickly. When you have these kind of monolithic data warehousing platforms, it's very difficult to adjust to these kind of changing business needs over time. So these are our main drivers. Again, we want to be more agile, we want to be able to react quickly, we want to be able to experiment and get out not just quickly, but cheaply. And we want to be able to take advantage of these kind of new infrastructure possibilities that are provided by the cloud. And ultimately, this leads us to being able to have a lower upfront investment, quicker returns on our investment, and ultimately that ability to make those actionable insights. Again, if you do contrast this with a traditional data warehouse, we're typically talking about development periods that are measured in weeks, sometimes even days if it's a small type of experiment, compared to months and years on that kind of traditional data warehouse side. So, as a result of these kind of drivers, data warehousing is evolving. Our new primary characteristics around a modern data warehouse, or at least what we would classify a modern data warehouse. And this is important because we can take that monolithic data warehouse as it exists today, and we can just pick it up and we can move it over into the cloud. That does not, however, make it a modern data warehouse. It needs to have some certain characteristics for it to kind of qualify for this. The first one that I'm pointing out here is modular. We need the ability to kind of swap in and out components. Maybe I don't have an AI need today. Maybe I don't need machine learning and so forth, but I know that it's coming. Or maybe it's even more transient where I need it for a period of time to do a specific project, and then I want to throw it away. That ability to do that swap in, swap out, and allow us to grow with our business organically is a huge component of a modern data warehouse. Being able to be elastic is another. Part of this is the return on investment side of this, where we can scale up and down and out and in as we need on demand. But a lot of this is also just our ability to be agile with our business needs. You especially see this in seasonal organizations where they do need to, over a seasonal period, be able to scale up and then scale down later. But most organizations have some level of this sort of elastic need. The last major characteristic here is the data warehouse's ability to be fluid. And when I'm talking about fluid here, it's really just being able to handle data coming from anywhere, at any rate, any size. For a lot of organizations, this is still just going to be relational data sources, but other organizations are going to be pulling in things from IoT sources in real-time streams. They're pulling in sources from third parties, from public sources like sentiment analysis off of social networking, all sorts of places. And we need the ability for our data warehouse to be able to ingest that data and provide it up to our end users without it being a whole extra process. It just needs to be natural as part of how we handle our data. So from a component perspective, another thing that's important to understand is almost all of the services that we're going to talk about today are bifurcated to some extent. They tend to either be a storage service or they tend to be a compute service. And when we talk about this is a little bit strange to a lot of database administrators because when you look at something like SQL Server, it's largely handled by a single engine. Our storage may still be off in Lasan somewhere or so forth, but the management of that storage still tends to be held very closely to the data engine itself. A lot of these modern services, again, that we will go over, don't necessarily have that. They decouple that storage and compute element. In fact, this is largely how that elasticity is achieved because it allows us to independently change our compute to our storage. Was there a question? All right, we can continue. So again, just keep this in mind as we're looking at these components that they tend to fall into this. The line is not always super crisp. Sometimes there is some overlap and there's some shadow in there. But generally, when we talk about components in this kind of modern approach, it's either a storage component or it's a compute component. So let's look at Microsoft's spin at this. Before we get too far into this Microsoft's approach, what I want to start with is that Microsoft's approach here is also evolving. We're going to start by talking about this from a distinct component perspective, But we're going to end this conversation talking about kind of a unified experience, specifically under Azure Synapse Analytics. But that is not necessarily the route that you have to go. It may be a preferable route. It may not. And we'll talk about some of the little pieces of that as we go. But again, we're going to start by talking about some distinct services that are very common in this kind of a modern architecture. So we'll talk about Synapse Analytics. We'll define what that is and kind of explain it. We're going to talk a lot about Azure Data Lake. We're going to talk about Power BI, Data Factory, Databricks, and Azure Analysis Services. Plus, there are dozens and dozens of other miscellaneous services that can be tied in here for purpose-built solutions. We'll touch on some of those, but we're not going to go in a lot of depth there. So let's start with Azure Synapse Analytics. We'll talk a little bit about the timeline with Azure Synapse here, but the main thing I want you to understand is where Synapse's roots are is with SQL Data Warehouse, and more specifically, what used to be the on-premise appliance, which has gone through multiple name changes too, but it was SQL Server Parallel Data Warehouse for a while, and then it was SQL APS and so on. But it's a massively parallel processing database engine specifically optimized for a data warehouse workload. That got ported into the cloud and was originally, again, named SQL Data Warehouse. It has since been kind of transformed into the Synapse Analytics. And it's part of Synapse, and we'll get again into some of the details here. Earlier this year, Microsoft introduced a new concept in Synapse called a workspace, and this kind of acts as an umbrella to bring a number of Azure products together. It gives us a single pane interface to manage essentially our entire modern data warehouse architecture. And so from this single pane, we're able to control things like our list here, Data Lake, Data Factory, our SQL pools, that's the kind of the new name for the data warehouse, our on-demand instances, which we'll go into quite a bit of detail later in the demo, things like Power BI, Apache Spark, so on and so forth. There's a lot of things that kind of fall under this umbrella in Synapse, which is again why, as we kind of walk through this, we're going to be circling back around to Synapse as kind of the centralized topic here. Other standalone services is Data Lake. If you're not familiar with Azure Data Lake, this is kind of the next evolution of Microsoft's cloud storage, which used to be just known as blob storage or something similar to that. It's just a centralized cloud-based file system. Think of it that way. The main difference between it and blob storage in Azure is that it supports hierarchical storage. That's just a fancy name for it supports folders. It's really that simple. Blob storage, on the other hand, is a very flat storage system. It's just a container filled with objects. We oftentimes fake a hierarchy in there by naming it to look like it has a folder structure, but from a technical perspective, it's flat and it's just objects in a container. Data Lake is not that. Data Lake is a massive scale file system that supports folders in the cloud. Again, does not seem very special on its own, but it is when you start combining it with some of these things. It also follows a pattern that you see Microsoft doing a lot today in their technology, where they have a proprietary system that they've designed, like this Azure Data Lake, but they expose these proprietary systems using open source APIs. So Azure Data Lake exposes itself as a Hadoop compatible file system. So most Hadoop compatible tools can connect to Data Lake directly without it even knowing that it's talking to Data Lake. It thinks it's just talking to a Hadoop cluster somewhere. And you're going to see this pattern over and over again, whether we're talking about things like Azure Cosmos DB or what was brought up earlier with Azure Pureview. The Azure Purview service actually is mimicking some of the Apache open source metadata repositories so that other tools can talk to it. Again, it's a very common pattern that you're going to see kind of from Microsoft's perspective of how they're positioning these proprietary technologies. It's very, very open, and it's what allows us to have some of those modularity features that we talked about earlier, because we don't really care about the specific. We can swap it in and out with other tools as we need. Power BI, hopefully everyone's familiar with that. It's the #1 data visualization platform in the world now. There are millions of users every single day in Power BI, and the service is very tightly integrated into this modern kind of platform. And we can go into some of the details about this, and we'll see a little bit of an example of this. But in general, Power BI is our visualization layer in these modern platforms from Microsoft's perspective. We also have Data Factory. This is kind of our glue that binds everything together. It's an orchestration engine primarily. However, recently there's new additions to Data Factory that allows us to do more of a data flow that utilizes Apache Spark underneath and has aspects of some Power Query, if you're familiar with that from the Power BI world too. You can kind of think of this as similar to SSIS. It has a lot of similarities, but there's also a lot of differences. At its core, Data Factory is closer to kind of the control flow inside of an SSIS package and not necessarily the data flow. So it's more about that orchestration side of it, but it's orchestration that is highly scalable. It's largely serverless, and so you can use it for very large workloads or very small. It scales, to handle it all. Another common component in a modern data warehouse, especially when we have big data type of scenarios, is using Azure Databricks. This technically is not a Microsoft product. Databricks is available on all of the major clouds. There's an AWS Databricks and so on. Databricks works with the cloud vendors that have tight integration in those platforms. And so Azure Databricks is tightly integrated into Azure. And what it is it's a Spark-based analytic platform. So Apache Spark is kind of an in-memory variant of Hadoop for big data workloads. Databrick is that plus some. And that plus some is this cluster management and the optimization and things like a workspace and so forth. I'm not going to go into much Databricks detail, but it is typically part of what you'll see in this modern data warehouse. Next, Azure Analysis Services. This really is not any different than what you might be used to for on-prem, with one major exception. It only supports tabular models if you're familiar with analysis services. It does not support multidimensional, at least not today. But this acts as our kind of semantic layer inside of our modern data warehouse. Although this is largely getting replaced with the functionality that's going into Power BI, especially around things like Power BI Premium. There is still absolutely a place for this, though, depending on what your organizational needs are. The last specific service we're going to talk about is what was mentioned earlier, and that's Azure Purview. So brand new. It's in preview. It's been in private preview for a little over a year and a half. And I've been using it, I think, in private preview for at least a year now. And this was meant to be the second generation of Azure Data Catalog. That is where it was started, is they kind of have abandoned Azure Data Catalog. It's technically still out there, and you can deploy it right now if you want, but there is no new development that's going on against Azure Data Catalog. And there's some technical limitations there that drove them to doing a second gen and basically abandoning that code base and starting over. Somewhere along that path, though, of doing this second gen of data catalog, Microsoft acquired a couple companies specifically to address some of the data privacy concerns coming out of Europe. And they transformed this product to be much, much bigger than a data catalog into this kind of unified data governance platform. It still has the catalog aspects where it'll auto-discover your data. It will kind of describe all of that, but what is built onto it, and unfortunately, a lot of these features are not available in the public preview today. Some of them are still private preview, but there's a full rules engine as part of this that allows for data classification and applying things like data masking and security policies, and all sorts of things. This goes far beyond analytics. This is something that can be applied to data no matter where it lives within your organization. And I strongly suggest you guys track kind of what's going on here, because it's going to be very important coming in the near future. The next major update for Purview should be somewhere first quarter. I think actually end of January is what I was hearing from the team. But you can use it now. It is available in a preview form, and certainly kick the tires of it. This, though, until recently, it was kind of the missing component from Microsoft's solution. Since they, as I said, kind of largely abandoned their original data catalog, we didn't really have a good data governance and metadata layer inside this modern data warehouse, at least coming from Microsoft's perspective. That's now changing, and it's changing greatly, because this is set to be a game changer type of tool. It's very, very cool. Maybe if you guys would like, I'd be happy to come back at like a future date and we can kind of dive into Purview specifically. I did mention though miscellaneous. These are just some common ones that we will see in the data warehouses that we're deploying today. Things like function apps. It's just a serverless container for some bit of code in Azure. It's very useful for augmenting ETL processes, that sort of thing. Cosmos DB, I'm going to talk a little more about that later, so we'll skip it for now. Things like Event Grid, so I can do event-driven processes. Instead of everything being batch-based, maybe I want it to be based off of an event. Maybe a new file dropped in my data lake, and I want to use that to initiate an ETL process. That's the type of thing that Event Grid allows us to do. Logic apps, it's kind of a simplified workflow engine in Azure. If you're at all familiar with like Power Automate and some of those tools, which is also listed here, those business-focused ones, it's kind of the IT version of Power Automate, low-code workflow engine. Azure Machine Learning, a lot of these functionalities are pretty important to this overall schema, but again, it tends to be a little more niche and advanced for most organizations where they are in their maturity kind of curve. IoT Hub is hugely important if you have any IoT data that's streaming in. There's a number of ways of dealing with that in these kind of models, but it's very much a common component. And then, of course, all the other business-ready apps that go along with the Power Platform. That said, though, at the beginning of this, I explained that one of our goals for a modern data warehouse is that it's modular. And that is very much true with this kind of Microsoft world as well. You don't like Data Factory, you prefer maybe Informatica in the cloud, go ahead. It fully supports all of the tools that we're mentioning tonight in terms of like a platform. You don't want to use Azure Spark, or you don't want to use Databricks, Cloudera works just fine, and so on. These are just 4 quick examples kind of showing the different components, but there's hundreds of partners that work with these Microsoft kind of ecosystem. And it is so much easier integrating these kind of disconnected systems in this modern architecture compared to what it was in that kind of traditional sense. Usually when you bought into one of these systems, let's say like Informatica, you had to buy into the whole thing. In this kind of more modern world where things are modular, I can kind of pick and choose where it's appropriate. So it's another just important distinction. So while we are spending a lot of time talking about the Microsoft aspect of it, it really doesn't have to be Microsoft. It can be way more agnostic than that. Now that we've talked about kind of the components, or at least the service side of this that potentially makes it up, let's look at an architecture diagram and see how it kind of differs from that traditional one. The first thing I would kind of point out here is these kind of gray boxes that are in this architecture diagram. All of these, again, are modular. Maybe I don't have a data exploration need, so I don't necessarily need to apply that kind of SQL analytics layer. And by the way, what that SQL analytics is, that's the serverless SQL engine that we'll talk about here in a moment. Again, I know I haven't really explained much about that yet, but we absolutely will. It's gone through a few name changes. It's no longer called SQL Analytics, but we'll brush over that for now. But you have things like Data Factory. Active Directory tends to tie all of this together. And our centralized storage platform, as we talked about earlier, is Azure Data Lake. And again, we'll get into some details with how these things tie together and what they're doing in there. But we have a very modular system here where I can kind of pick and choose and add things. And it all works homogeneously together, however. Our life cycle changes as well. The life cycles tend to be very much a cycle in these cases where we start off with things like just ingesting. This is something borrowed from kind of the big data world where we don't necessarily worry about the quality of the data or what we're doing or even the structure of that data. We're just going to ingest it. We're going to store it somewhere, and that somewhere is our data lake. We'll write it now. We'll clean it up later. We'll worry about whether we have all the right stuff later. And there are pros and cons to this, of course, a lot of cons. There's also a lot of pros to it. But in general, the idea is we ingest now. We'll figure out the details later, which leads us into that next step of that kind of exploration and discovery. We need to be able to find the value in all of that junk data that we're dumping in our lake and be able to kind of pick out the gems out of it. And this exploration is that part. Once we found it, we can then curate it, prepare it, potentially use it to train models for machine learning, those type of things. But this is where we start to extract our value. Once we've identified it, we've found some value in it, now we might formalize this into more of a data model that supports reporting. You'll see here in a moment that we can start reporting off of this almost immediately. However, that kind of quick and dirty thing is not necessarily from a life cycle perspective where you end up. At some point, you want to end up with some formalized certified model that is displayed to the wider audience of your enterprise. This is where we start integrating that data also into downstream systems. That's another important point that I've kind of glossed over here. These modern data warehouses are oftentimes just a part of this greater chain. This data gets integrated back into the operational systems. A lot of times in a traditional data warehouse, it's one directional. The data flows in and it never leaves that data warehouse except for the reporting purposes, but it's not necessarily being used to drive operational processes that are downstream from it. That kind of is thrown out the window with these modern data warehouses. They are integrated as part of the operational systems in a large degree. Again, it's going to depend on your organization's maturity around that, but it's definitely one of the goals of these systems. And again, our last kind of step here is that visualizing and distribute it to the rest of the organization or whoever the consumers are. Could be outside of your organization. It doesn't really matter. And then this cycle repeats. So I mentioned we would bring this all back to Azure Synapse. And that is exactly what Microsoft's been doing, as they're trying to circle their wagons around a single unified platform. And that unified platform is Azure Synapse. So a little over a year ago, on November 4th, was the initial release of Azure Synapse Analytics. At that point, there was no new features. Azure Synapse Analytics was just a rebranding of Azure SQL Data Warehouse. There was a lot of promises of what was to come, but it was really just a rename. It wasn't until May that we started actually seeing this vision come together. There were a handful of small updates in between November and May, but the big update was in May when Azure Synapse Workspaces, which we'll go into here in a moment, went into public preview. This is what introduced this concept of a unified studio that we're going to demo here in a moment. But that is that umbrella that I was talking about that spans a number of different services and has it under one management window. It's very, very important. And from that span of May until just a couple weeks ago, on December 3rd, there has been hundreds of new features released. Literally hundreds of new features, some very, very cool ones that we'll talk about, and some of them we'll demo, and it's hit general availability. At the same time on December 3rd, a whole new set of preview features also went into place in Synapse. So there are some components of Synapse that are still under preview, just to be clear on that. But in general, the platform is generally available, meaning it is production ready. I can tell you that we've had production workloads in Synapse since well, basically since it came out. So it's been ready largely for production workloads for a while. It's just maybe missing some features as it has come along. But the development pace of this is very, very rapid, especially when you compare it to something, say, like SQL Server, that right now SQL Server is kind of at its pinnacle of release cycle, where it's happening about every 2 years generally. We're now talking about release cycles that are measured in months. Usually there's a new release every month. So it's very drastic changes that are occurring in some of these environments. So that December 3rd release kind of led to this unified concept. We have an ecosystem of data, and that data can live anywhere, and we'll talk about how that's accomplished. We have things like Power BI for our visualization. Again, though, this is modular. This could be Tableau, it could be Qlik, it could be whatever. It doesn't have to be Power BI. We'll point out that Power BI does have some special integration that may may kind of tip you towards using it, absolutely. And then we have, this is relatively new, but the incoming of Azure machine learning as well, of kind of bridging these together. All of this under this one umbrella of Azure Synapse. So let's look at the kind of the architecture here. So first, from a platform perspective, Azure Synapse is built on top of Azure Data Lake Storage. The Data Lake Storage component is separate from the Synapse, but Synapse is managing it for the most part from a platform perspective. But there's a reason why it's kind of drawn outside of the blue box here, is because it is set as a separate storage medium. And there are some reasons for this too. It's to help facilitate some of that integration with other services. It was on the slide, but I didn't necessarily mention it, but Azure Data Lake, having its base in Azure Storage, meaning the blob storage, makes it a universal service. It's deployed to every single Azure region, and essentially every Azure service has the ability to write to it. This is what makes this a very, very powerful platform for our data lake. If you have existing services in Azure, you can essentially turn on their ability to write to the data lake right away. It's natively supported. But this data lake integration also has some integration functionality with things like Dynamics and things like Power BI, namely Power BI's version of data flows and their common data model, which I believe was recently renamed to Dataverse, is what they're calling it today, but they keep changing names on this stuff. So then within the platform, we have some just general management considerations. We have a centralized portal to manage security. We have monitoring, and then we have a meta store. We'll be going into the meta store in more detail in a moment. This then includes our data integration layer. Our data integration layer is Azure Data Factory, primarily. It's no longer called Azure Data Factory inside this world. It's a first-class citizen inside of Synapse. It's just called pipelines and data flows, and we'll see that. So there really isn't any distinction here. And for the most part, it has feature parity with Data Factory. There's a couple little nuances that aren't particularly important, but there are a few differences here. We then have our runtimes. We have two primary runtimes. We have a SQL runtime. That SQL runtime is in two flavors. We have the provisioned SQL runtime. That is what used to be called Azure SQL Data Warehouse. And we have this on-demand or serverless runtime, which we'll again look at. I keep kind of teasing it, but we'll get into it in a moment. So that's all within this SQL box. So this starts to be our compute layer. This is what's doing a lot of the work for us. And then our second one is our big data side for big data processing, which is Python, and it supports a number of languages, everything from Python to R to you name it, .NET, so supported there. These form factors are kind of, this is talking more about the SQL side, so we have the provisioned and the serverless. And then, like I said, there's a number of languages. Multiple languages suited for different workloads and for different development styles. If you're comfortable with Python, go ahead and use Python. If you're more comfortable with SQL, you can use SQL here. But this is kind of how all of this is layered into this one little window. And it's exposed to your developers through the tool called Azure Synapse Studio, and this is a web-based portal. This is essentially the workspace in a nutshell. We'll look at it though. And again, it's designed to take a bunch of different scaled workloads. The scale side here is actually what's most exciting to me. It isn't the big data side of it. There's a lot of tools that we've had, a lot of enterprise scale tools we've had for quite some time that can handle massive data volumes, and the variety of data and the velocity of data has all been handled quite well. It's actually the small side that excites me the most. Because of the way that this is modular and I can kind of pick and choose these parts, this allows very, very small organizations to deploy world-class data warehouse solutions for very small amounts of money that can grow with them, because they don't necessarily have the need for something like a big data solution today. But they may in 5 years, they may in 10 years, whatever it happens to be. But this opens the door for essentially any organization to be very active and strongly capable in a data analytics world. That has not been the case. That definitely was not the case with the traditional data warehouse. They are very, very expensive. And don't get me wrong, this solution can also be very, very expensive, but it's very expensive when that sort of compute and storage is actually needed. And that isn't the case for most smaller organizations. They can get away with much more modest deployments of this. In fact, you can go deploy an Azure Synapse workstation right now, or it's not workstation, so workspace for free. It doesn't cost anything to just have the shell there. What costs is when you start using some of these add-on services. That's where the costs are coming in. So another exciting thing to me about Azure is the Azure Synapse is some of the integrations it is getting elsewhere. The first one here is this Azure Synapse for Cosmos DB. I would point out that Microsoft has strongly hinted that this sort of thing is also coming for Azure SQL and some of the other database platforms, but it's not here yet. But what this is it allows you to essentially flip a switch in your Cosmos DB environment and take that transactional data store that you have there and auto sync it to an analytics store that is already pre-optimized for analytic workloads. There's no extra overhead. It just happens in the background. The overhead's consumed on the cloud side. You don't see it. And it's near real time. It's very cost effective, and it doesn't require any ETL. I can link that directly from something like a Synapse workspace and start querying it immediately, just using some standard SQL tools. It's very, very cool. So if you have these kind of an operational system where I am feeding data into something like a Cosmos DB, you automatically can get that analytics side of it without any new ETL development. So if this happens to come to something like Azure SQL, I think that'll be a very big game changer. But for now, it's a Cosmos DB feature. So our architecture does change a little bit when we talk about from a Synapse perspective, because now it is all under one umbrella. It's essentially the same thing that we saw before, but it's all managed under this Azure Synapse. And we have some different terminology here. We have things like Synapse pipelines, that's Data Factory, things like Synapse Spark, which is, again, that Apache Spark nodes and so forth. So let's hop out of here and go into a demo. You should be able to see my screen. I am logged into the Azure Synapse Studio, or this is a Azure Synapse Studio on top of a Synapse Analytics workspace. It's just a simple demo environment. This is what you're greeted with when you kind of log into this environment. Most of the navigation is handled over here on the left side, and I'll try to zoom in. Hopefully this translates well to the Teams. But our navigation is broken into a few things. We're actually going to start down here on the bottom on the manage, and we're going to kind of work our way up. So under manage, this is where I keep using that kind of term umbrella, but this is where our umbrella lives. This is where all of our objects, wherever they live in our ecosystem, start to come in. Inside of here, we have our analytic pools. These are the compute nodes that I talked about. So we have our SQL ones, which is what I'm looking at here, the SQL pools. Again, this could be provisioned, like I have a provisioned one right here. And then I have this built-in serverless that we'll talk about in a moment. Also have an Azure Spark pool. So this is an Apache Spark cluster. It's fully managed. I can define the extents of it, how many nodes I want, and it'll auto scale, it'll auto pause. It does a bunch of those things. So it has very, very similar functionality to what you'd expect with something like Databricks, but it's just built into the Synapse environment. This linked services is everything else. So I only have a few things here. I have the analytics stuff that we already were talking about. I have a link back to a Power BI workspace, which we'll look at the integration. And then I have an on-premise SQL server. If I click this new, however, and let me zoom out for a moment so we can see this, it brings up a pane. These are all of the different services that I can connect to with this today out of the box. So everything from other clouds like AWS services, to other Microsoft services, to generic things like ODBC connectors and so forth. There are a lot of options to be able to integrate data into this and then start to be able to manage those workflows around that data. But that is managed here under these kind of linked services. And just moving down, triggers. I don't have any triggers created here, but a trigger is just that. It's either like a scheduled trigger that I'm kicking off some sort of job, or it could be event-based and things like that. It can also even just be an HTTP, kind of like web service endpoint that another service calls to initiate something. Integration runtimes, if you're at all familiar with Data Factory, this is the same concept. I have a few different types of integration runtimes. This is what allows me to reach from the cloud into an on-premise data base on an on-premise network, for instance. This is that kind of gateway that allows me to resolve that. Access control. There's a number of roles that are defined as part of this service. We can kind of look at them, but we have different administrator roles, we have different user roles, operator roles. This is where we manage that sort of thing, is in here. You assign people to these roles and they have different permissions within this environment. We also have the ability to tie into things like an Azure Key Vault for password and username storage, and we can define them as credentials that other services within Synapse can use then, so we're not hard coding usernames and passwords all over. This managed endpoint, this is for getting private network access and so forth, and we also have Git integration, either with Azure DevOps or just like GitHub, places like that. Monitoring, this is largely what you'll see inside a Data Factory, plus some, because we also have the ability to monitor our Spark instances, monitor our SQL requests, and so on.
We got ahead.
So next, we're going to actually jump up to the top. We're going to look at our databases. So as I mentioned, I have two SQL pools attached to this. I have our default on-demand one, which I'll look at in a moment, but I have this provisioned one, which I'm not sure if I even have any tables out here defined, but we can probably change that here shortly. And then we have the Spark instance, which you can have tables and things defined as part of it. This is that metadata kind of repository that we were talking about earlier, where we can actually define some of these objects independent of our pools, our compute, and independent of our storage, even to some extent, right? So I have a number of these data sets defined. This is just defining data that's living inside of any of these linked objects. It could be the data lake, it could be the data warehouse. This is actually the data lake itself, and this is where I'm going to show a few things for the serverless. So I'm going to connect to this data lake, and we'll take a look at it. And again, this is just a file system, right? That's essentially what this is. So if I go, let's say we have this customer, and it's a Parquet file in this case, which is a big data type, but it could be a CSV file. It could be any number of things. If I right click on this and I say I want to select the top 100 rows, and let me collapse some of this because the resolution is a little small. It is going to create a SQL statement that's going to go out and interrogate my data lake. That file uses this open row set. This is standard SQL. There are a few additions to this, but it's standard SQL. It's using the built-in. If I hit run, let's get close on this property. It's going to go out there and it's going to issue the query and just do a select top 100 here. And we can see that. This on-demand instance of SQL Server can be connected to via Management Studio, essentially any tool that understands SQL. This is where some of those possibilities for those smaller organizations come in, because now I have the ability to actually build things like a virtual data warehouse where I don't have a formal engine on top of it. I just have a data lake with this on-demand instance that spins up as I need it. You just saw I returned this data in about 6 seconds. That is cold. If this was warm, it would likely be much quicker than that. We can try running it again and see what it does. So it's about a second when it's warm. But that instance that it's attached to in the background happens all automatically. It's all provisioned for us. And it all auto scales too without us having to do anything based on the number of files and so forth. And so let's actually jump into what some of that looks like. Because I have a number, again, we're talking about kind of this metadata layer here. I have a number of queries that I have set up. So let's look at what it looks like to query a CSV file. Here's a CSV file. And this CSV file, because it's just a flat file, now I have to augment my row set with some actual column definitions. So I'm giving it some extra information so it'll apply the proper data types and so forth to this file. But this is just going to do a quick count. So we'll let it run, and it's doing it against this kind of sales.csv file. And it'll go out there again and interrogate it. So this file has a little over 4 million records in it, and it interrogated it. I will tell you, things like flat files are considerably slower to query than something like a Parquet file. If you're not familiar with Parquet, it's essentially a columnar database in a file format. And so it allows us to have things like indexes and stuff as part of it, compression as part of it, and those type of things. And so like that, this is that example of doing that Parquet file. No column definitions are needed because metadata comes as part of that file format. Here is another example. This is an example where I'm actually going to create a table in my provisioned data warehouse. I mentioned that we could pull data from just about anywhere. That's true. This data lake that it's coming from here is not mine. This is a publicly available part of Azure's open data storage platform. So it's coming from a public data source and it's connected to my DW. I'll run this and it'll load a bunch of data. This will take a little bit of time though. It's a pretty big data set. So another just thing, I'm not going to necessarily demo this, but there are some other extra features as part of this. I have the ability to do wildcards inside of my query for the file system. I can also take this and break it out as parameters. We have some special function names like file name here where we can get the file name of it. So again, this might be a little hard to see, but I'm doing an in statement where the file name matches one of these. So it just returns a subset of that data. There's a number of these ways that you can kind of manipulate it. You see that I have multiple wildcards in here. I can reference that as part of my file path by putting in the number, and then I can replace it. So I can say where, in this case, 2017. So I'm only pulling 2017 data, and I want it to be October, November, and December. So there's a lot of little extra flourishes to the SQL syntax that allow us to query these big data systems, these data lake systems. This is the on-demand serverless instance. I can use this to query other things too, by the way, but for our purposes, we primarily are using this for the data discovery portion inside of our data lake, or we could be using this as a bit of a virtual data warehouse for something like a small organization, because I can connect Power BI to this and I can start querying directly against my data lake using these type of statements. Further, I can actually create databases inside of my serverless instance, and so I can predefine some of these things. Instead of doing this select on demand, I can mount this as an external table, or I can create it as a view. There's a number of things I can do here. So all of this that we're looking at here is part of the development options inside of Synapse. We can develop a number of things. You see we have SQL scripts, what we've been looking at. We have notebooks, data flows, Apache jobs. We can even develop Power BI reports. I mentioned that, again, once you start integrating some of those linked services, I showed I had a linked service here for Power BI. I can start to see the Power BI stuff. It just shows up. So I can click this and it will open up a new tab and it's going to go out and hit this report and pull back the data for me, or at least it should pull back the data for me. While that's kind of chugging away, we can look at a few other things here. We have notebook functionality. If you're not familiar with notebook, this I think kind of originally came out of the data science world with Iron Python back in the day and so forth, but today it's evolved a lot. But essentially this allows me to kind of have a narrative of data exploration. I can have all of this code sets, have text to describe it. I can integrate visuals inside of this, and it's interactive. I can come through and actually run these and have it update against the data. It's a cool concept. You're starting to see this elsewhere too. If you're familiar with like the new Azure data tools and so forth, a lot of them are using these concepts around notebooks and so on. Data flows I've mentioned a little bit briefly, but this is the data factory kind of data flow side, so the SSIS. This allows us to actually do record by record data manipulation inside of it. Let's see if my report ever loaded. It does not like me. The last thing to kind of talk about here is our pipelines. This is data factory inside of Synapse, and it is just data factory inside of Synapse. If you're used to data factory, this is the same thing. There's nothing really new here. It's just data factory there. On that topic though, if you do happen to go take this and play around with it, you'll notice under some of these menus, they'll have this option to browse gallery. This will launch the gallery, the community gallery. There are dozens of different samples in here that show you how to use different features for different languages. There's public data sets that you can use just to play around with data. There's sample SQL scripts that show, again, a lot of the different features, like for instance, exporting data to a Parquet file using create external table as select statement. There's just a ton of stuff here to play around and kind of learn how the environment works. It's pretty cool. And the possibilities, I think, that it opens up are even cooler. And we are doing dozens and dozens of these with clients of all sizes, some very large, some very small. It fits pretty much everything. So with that, I want to open it up to questions. Are there any questions here around any of this?
I don't see any questions. I don't see any questions in the chat window.
Yeah, I think, Pierre, I think you've mesmerized everybody with this presentation. It's really quite good.
Thank you. I appreciate it.
I had a question early on about joining Parquet files, but you really answered those with this with the demos.
And there's a wide variety of data types that are supported. I mean, we're using Parquet just because it's easy, and like I said, Parquet has some performance advantages, but we can use a wide variety of different file types. We can even create custom connectors if we actually want to go through the problem of developing it. Maybe we have a proprietary binary file format from an old system or something like that. Well, we can likely write a connector for it and make that work. But there's a lot of options here depending on what you're trying to do. And you don't have to do the big bang solution here either. You could just deploy this workspace, have it attached to a data lake, and maybe you're just using it for some simple data exploration for today. Maybe eventually that grows into a data warehouse, maybe it doesn't. It's really why you're starting to see, although we're labeling this as kind of a modern data warehouse platform, that term is largely going away because the lines of what a data warehouse used to be and what it's now kind of becoming are starting to blur, because this is as much as an operational system as it is an analytic system.
Well, I've been noticing that within my own company, as well as attending various conferences and such, that data lake seems to be the new database. What we're finding is that we use a lot of stuff for doing risk analysis. Work for an options clearing company, and there's constantly doing risk analysis on positions that are constantly changing on stocks, on portfolios, and at a moment's notice, you need to know if you have to make a margin call. And so a lot of this has to be done instantly. There's no waiting for data to be loaded into some sort of database and then be analyzed. So a lot of the modern analytical tools seem to fit the need for that.
Yeah, the data needs are also definitely changing, right? And like you said, the time to market is getting shorter on this. The volumes of data are getting larger. It's not necessarily getting any easier to serve this stuff up. If anything, it's gotten quite a bit more complicated and more difficult. But we haven't even really talked about kind of the more mature, advanced side of this. All of these services are backed by APIs and so forth, where you can automate a lot of this stuff. I have clients that are, on the fly, essentially have a portal that their users, their business users go to, and they say, I need this data set with this data, and it'll go and generate a brand new tabular model for them, deploy it out to analysis services, and now that's a transient data set. They might only need it for a few weeks, and then it gets trashed and thrown away. But it's all driven from an underlying data lake, because that data lake has it all somewhere. It's very, very easy for that to turn, you hear terms like data swamp and things like that. It's absolutely easy to do if you don't have that governance aspect of it, which is why, I mentioned earlier, I'm very excited about stuff like Purview, because that should help really start to make some of those things more transparent and manageable. Any other questions or even comments around, any of this technology? More than happy to talk about it.
Crickets.
Well, the other thing I wonder about, and I don't mean to monopolize the time here, but one of the things I wonder about is that there's a lot of talk now about doing multi-cloud, where you don't put all your eggs in one cloud basket. And so how would one be able to take this this type of methodology and port it over to AWS? Sorry, Microsoft employees.
Yeah. Well, AWS has a lot of equivalents for these things. They have their own kind of equivalent with S3 storage for data lake and things like that. And of course, they have their variant of Databricks and so on. Plus, they have their big data warehouse platform with Redshift and so on. So there's equivalence to a lot of this stuff. I personally think that they have failed in some of their approach. And I'll give an example. Is when they decided that they wanted to do a cloud data warehouse, they essentially just built an appliance in the cloud. And that's kind of what Redshift ended up being. And there's some advantages to that. It's quick to to get to market and that sort of thing. It's easy to kind of do some performance tuning and stuff on, where Microsoft took a lot more difficult route. They spent a lot more time separating that storage from the compute and doing it so that it could scale to a true kind of cloud scale type of scenario and so forth. And so the first few iterations of SQL Data Warehouse were not very performant, and we're kind of a pain in the butt, and we're not very feature rich and so forth, but they stuck with it, and it's very much paid off. It would be very, very difficult for you to replicate some of this clean integration over in, let's say, AWS. But you don't necessarily have to, because as you said, a lot of organizations don't settle for a single cloud. They're multi-cloud. We can access data from Synapse in AWS or Google's cloud or other private, clouds and networks and so forth. There is very likely going to have to be some level of data movement. And that is certainly a problem, because data does have gravity, right? Wherever that data kind of lands tends to be where we want to do the work on it, so we don't have to remove it and move it again and again and again and so on. But I can also tell you that the pipes between things like Azure and AWS are very, very fast. We had a client where we were copying over somewhere in the neighborhood of about 10 to 12 terabytes of data every couple of minutes between AWS and Azure using Data Factory. Very, very expensive pipelines, because we're talking about hundreds of data integration units and stuff running to do that. But it's possible. You can transfer very, very large amounts of data over very, very quickly if you need to. And in their case, they needed to, because their platform of choice is analysis services for serving that up. But their platform on the data side, where they're doing all their app dev and stuff, is in AWS and S3 storage and that sort of thing. And so they live in a hybrid cloud environment. So they have a little bit of both. And they, of course, still have things on-prem and stuff too. And so you just come up with solutions that kind of bridge that. There's nothing in terms of like Synapse here that is locking you into that kind of platform. If I want to connect to Redshift and query data, I can do that here too.
Hey, Pierre, you have a question from Scott?
And what's the question?
Scott, you have your hand up. Did you have a question, sir? Scott Burnside?
I think he did it by mistake. The hand raised.
All right, no problem.
I do have a question. Just interested if you could comment on security and network connectivity. We're starting a project regarding migrating our data warehouse to Synapse and potentially our data lake also. But a lot of our time is spent on trying to figure out connectivity and security. And I notice in the workspaces, a lot of the new, a lot of the security is still in preview, a lot of the RBAC and all of that. Yep. So I just was interested if you have any comments regarding security or what you've been through with that.
Yeah, that is something that's absolutely maturing still. So all of those preview roles that you saw, those were introduced earlier this month as part of the GA. That was where I was talking about. There are definitely some features here that are still in preview. The first version of Synapse is geared towards more of your management and administrative kind of users of this environment. It's not necessarily as geared towards the individuals that may want access to these systems. That doesn't mean you can't do it, but there's definitely some hoops that you need to jump through. I would also say that there's some immaturity there in terms of being able to lock these environments down. It's not that you can't lock it down, you absolutely can. And it's not that, it's just the flexibility that you may have there of doing this compared to some of the other Azure services. It's getting better, but it's not quite there yet. But keep in mind, this from a GA perspective is only a couple weeks old. From a out into the public perspective, it's a little over a year old, a year and a month or so. So it's a very, very new thing, and it'll evolve. I'm confident, though, that it'll get there because I've seen what they've done with other things like, let's say, Power BI and so forth in these rapid development cycles. But I'm just being honest, it's not fully there with all of that, especially on some of those more complicated enterprise scenarios. There's also layers of security here that we are kind of abstracting over, but we have, a complete security layer inside of the data lake. We have another security layer here in this workspace. We have another security layer inside of each one of those SQL servers. So there's some, crossover, of course, but it can get complicated quickly.
Thank you.
I think Scott was back with his question.
Yes, can you hear me?
Yes.
Okay, yay. Thank you so much for the presentation. I'm trying to learn Azure and Power BI and in the visualization side of things, but would you recommend a path to get certified in Azure or Synapse, or what if somebody's trying to get into this, because I do a lot of on-prem stuff and things like that. So Azure is kind of new to me. Do you have any I'd first get the Azure basics, and then I would get the Power BI, and then I would do this. Do you see a path forward for a generalist, or?
As of right now, there is no sort of certification coverage for any of this, and quite honestly, most of the kind of the analytics data platform side has been largely ignored by Microsoft recently. With some of the certifications, it tends to be more on the wider Azure platform as opposed to specifically drilling into some of these systems.
Right.
There's definitely training out there for components of this, though, things like the Spark side of it and that sort of thing. It just really depends on where your needs are, your interests are. But it's kind of hard to give me, some sort of clear little roadmap says, here, go here first, then go there. The best way that we've found is, just getting kind of dirty and playing around with it, right? Throwing some data in and seeing how it works. I know that's not always the best because it's not very guided, but I think that's what you're going to end up for now. Is you do see, though, on the screen there is that little learn button with the sample data sets and all of that stuff. Going through those tutorials will teach you a ton for sure, but it's still not exactly what I would consider like a course or, like a certification path. It's still a lot of one-off playing around.
All right, very good. Yeah, it's. I did. A lot of folks are throwing up some tips here. I appreciate that. It's a real big time investment. That's why I was inquiring if you had any guidance. But anyway, thank you so much. I appreciate it.
Not a problem.
Yeah, Scott, I would recommend because you've got kind of an on-prem database engine background, and I found understanding clustered column store indexes to be one of the real big starts, at least into this dedicated SQL pool side of this. That is really important. Once you understand that, then some of the other data warehouse concepts for massive parallel processing start to make more sense. And then once you get down the Spark and the Python, then there's a million different paths to go. But if you're thinking about a massive parallel processing data warehouse and that relational side, as opposed to a data lake of unstructured data, definitely start with clustered column store, because that'll make sense to you from an on-prem. And then you basically start multiplying that by 60, and you look at this introduction to Azure Synapse Analytics, which will start to break it down that way.
All right, very good. Thank you so much.
Mm-hmm.
The other thing I guess I would add to that, and I'm not here to sell you guys anything, but our consulting services, we do these kind of solution offerings that we call Jumpstart, and we have an analytics Jumpstart that is focused on Synapse, and it includes a fair amount of training. And it is lab-based module training, hands-on. It's not just us lecturing to you. Microsoft also has a program called Analytics in a Day. It's similar to their Dashboard in a Day that they have around Power BI. It's also Synapse focused. And they do, although these are a little hard to come by nowadays with the pandemic, there's a 4-day kind of dev program around Azure Synapse that partners can do. That's something, again, that we can implement as well for a client if it's something of interest. It's a 4-day, again, workshop that kind of goes around that.
Gotcha. Great. Thank you so much.
Thought I saw one more hand up, but it looked like it went down. Is there any other questions?
Yeah, I had a question. Yeah, just from a general perspective, so is Azure starting to pick up more amongst the big companies? Because I know a lot of the large companies, they want to have the data residing in their own data centers and not necessarily like Microsoft's. And so, maybe they, due to proprietary reasons, they want to have their own data reside in their own, physical servers and their data centers still. Are you seeing, big companies going with Azure nowadays, or?
I mean, the short answer is yes. I mean, that doesn't mean that there aren't exceptions, but we have some very, very large clients that are doing Azure at massive scales. A lot of them, from an analytics perspective, because that's the side that I come from, are being kind of driven there from things like Power BI and things like Power BI Premium. You have, a certain food company that's based in Europe that has somewhere in the neighborhood of 10 to 20,000 Power BI users using Power BI Premium, and a lot of that then gets driven over to Azure Data Lake as a backend and all of that stuff. So that drives it. But yeah, I do see a lot of large organizations. They don't seem to be as skeptical as they used to. Plus, again, this is way outside this topic, but Microsoft's been doing a lot of work to kind of bridge the gap of having Azure type services being able to be deployed in private clouds. Everything from like Azure Functions being deployed kind of in a local cluster to other things. So you can have Azure be kind of your management plane for data that lives both in the cloud and on-prem. So that it just depends on what you are looking for. I will say that there are definitely some companies out there that are holding out on any cloud, whether that's Azure, AWS, or whatever, just because they want the tighter control. But I would say, again, we keep talking about the pandemic is a driver for some of this, but it really is too, because we don't necessarily have office buildings full of thousands of people as we used to, at least not to that extent. People are working from home and spread out across the world. And so those type of things are also forcing the hand of some of these organizations.
And I know you just mentioned about Power BI, but I know Power BI, you can also get, people can companies can purchase, on-prem server license, so they can install it on their own physical servers as well, right?
Yeah, except it only supports a very small slice of the functionality that Power BI has. But you are correct. There's a Power BI server that can run on-prem. It's largely a rebranding of reporting services along with some Power BI report functionality there, but it's
quite expensive from what I've been looking.
It is expensive.
It's bundled in with your like SQL Server with software assurance, right?
Or Power BI Premium is
right.
Another way of getting it. Yes.
That's where you pay the big monthly fee, right? Like, was it like 5,000 a month or 15,000 a month?
Yep, that's another thing though that is changing. We have a new concept that's a premium per user, so you can do a per user license for premium features, although the pricing on that has not been settled yet because it's a preview feature. But there are some changes happening on the Power BI end. But you're correct. A Power BI premium instance, a P1, is going to cost you 5,000 or more, depending on what your licensing is and stuff. And could be way more if you get something like a P3, P4, that sort of stuff. And that is definitely not small to mid-sized business friendly when you're paying that every single month.
Yeah, I've been looking into that. Yes.
But if there's features and functionality there that you think would benefit your organization, but it's too costly, I would look at the new licensing around the premium per user. So, a standard retail price for a Power BI Pro is roughly $10 a month. This is going to be more than that. Again, they haven't settled on pricing, but it's not going to be thousands of dollars a month. So it's somewhere higher than that. Again, I'm not sure where they're going to land. You can try it out right now for free. It's, kind of like your, I guess, local dealer. They're trying to get you hooked, and then they'll throw the price at you later.
Well, I hate to interrupt. Boy, this is great. I could sit and listen to this all night. They kind of hit a nerve with me, but Pierre, I was wondering. I hate to put you on the spot like this, but would you share your slide deck with us? And
Yes, I can do that.
We can make it available to the membership, and as well as your contact information, if there's any other questions.
Yeah, that's absolutely possible. I'll wrap up the presentation and then send it over to you so you can distribute it.
Okay, thank you, Pierre. I really appreciate that. And thank you for speaking. This is a great topic. And Steve, thank you for the thank you both for the sponsorship.
It's our pleasure.
This was really
Sure,
great.
we can do it in person.
Yeah, that'll be great. We can never get to the point where we're not quarantined anymore.
Well, as Pierre said, we are passionate about this, so we have a big team here. If you have any questions or concerns or anything you want to know about later on, I'm sure we can help you find a path forward on using the Microsoft tools we went through today.
Okay, all right. Well, thank you both. We have some other announcements to make. Amina, who's speaking next month?
So next meeting is on January 14th, and then David Clay is speaking. And we are not sure about the topic, but we are sure it will be great. We had him last month, or a couple of months ago. He's speaking on January 14th. And then I think we are also going on a new environment that Jared may be talking, or we will be sending you the email that you will be getting the email from different address. But Jared, you want to talk about it now, or?
Yeah, I'll just mention this briefly. I'm sure a lot of you guys saw an email come out today that PASS is officially dissolving and cutting off all of their services on January 15th. If you didn't see that, this may come as a surprise. So PASS is going to cease to exist as an organization. Something you may not have known, though, is that these user groups are actually not a part of PASS. They're kind of like we represent PASS, and we of course talk about PASS, and they give us a lot of tooling, but we're not directly related to them, meaning that we do not cease to exist when they stop functioning on January 15th. However, we do use some of their tooling to send out our emails and stuff like that, and because that is your private data that you've given PASS, they do not give your emails to us. So what we have decided to do, as a lot of other user groups have done, is started a group on Meetup. I just set that up today, and so it's got to go through like their 24-hour little approval process or something like that. But we're going to use that as our platform to set up our future meetings and to and to have you register your emails with them. So we'll have that one central location. And so, but you will probably see an email blast coming from our typical email, because we still have that tooling till the 15th. We want to make sure we cover everybody and get you guys to sign up. So, if you want to get the notifications from us, like you probably did to come to this meeting today, it's probably starting tomorrow or within the next couple of days. You can search for the Chicago Data Professionals is what we're calling our group now, and that group will be on Meetup. We don't have any specifics on what we're changing with our website and stuff like that. We're trying to get that all figured out. But if you can find our group on Meetup, which again is Chicago Data Professionals, and I'm going to throw that in here. I bought the domain as well. So we've got chicagodataprofessionals.org. We'll see if we use that sooner than later, but just make sure to look for that. Look for an email coming out from us with any details, because everything's kind of tentative right now. I paid for Meetup and we're registered, but a lot could change because we just want to get it right. This is really your user group. It's not mine, Ross, and Amina's, right? It's yours. And so, if you have any feedback for us, feel free to send it to us. A lot of you probably have our emails. If you just want to send it to me, or if you have one of our emails, shoot out something, and then we'll include the whole group in a back and forth. But for right now, we're going to start by going to Meetup. That seems to be what a lot of people are doing, and maybe even have been doing. And we may even set something up in something called Azure Tech Groups. We're still kind of deciding about that. It is a Microsoft run kind of group setup, but at the same time, we don't know that we want to restrict ourselves to Microsoft Azure, because we are Chicago Data Professionals. We're kind of keeping it a little bit agnostic at this point, but we'll just kind of see what everybody wants to do, and we'll take your feedback. We'll probably even be sending out a survey through SurveyMonkey to try to get people's opinions on maybe what direction we should go. You're seeing us do a lot more Azure, big data, data and AI, not just SQL Server, and certainly not just on-prem. And we think that that's just kind of the route we need to go, because we're all moving in that direction. I learned Azure Synapse Analytics over the past month for a particular customer. As somebody mentioned earlier, this is a very, very large customer. You would recognize the name if I said it. And there's ways to get there, and we're all going to kind of have to at least have a little bit of knowledge about all these different technologies and how they fit together. So we're going to try to all get there together. I think we got a strong community here in Chicago.
Absolutely.
So without me being so long-winded, I'll just cut it off there and say keep your eyes open for an email from us, and we'll try to get you registered on the new platform.
Yeah, I like to think of us as we'll still be SQL Server, but a whole lot more.
Yeah, exactly. I mean, we're certainly not going to give up our roots here. I mean, we don't have a lot of people coming in here that are strictly working with Oracle, right? Most of our backgrounds, I would assume, still come from a SQL Server background or a Microsoft analytics data platform background. So we're going to keep things centered around that. But you never know when things might pop up, and we'll just take your guys' feedback and see how that goes, right? We pay attention to how many people show up at meetings too. So if we ended up doing something with I don't know, just as an example, what is it, Amazon Aurora or something like that, and only 2 people show up, maybe that's not our user group. So we're always open. We're here to manage the group for you. And volunteer our time to help make it easier on you. But ultimately, this group is the users. It's the only reason it exists.
Great, Gil. Ray Gill wants to know more about IMS.
I don't even know what IMS is.
It was the
You
forerunner
youngster.
of DB2.
But I am going to I'm going to stop the recording. I mean, if people want to hang out and talk, that's totally fine. You are free to do that. But